Hello, my name is Dr. Irfan, and I am Instruction Assistant Professor at Marine Engineering Technology Department, Texas A&M University, Galveston. We have this lab. We have actually two different labs in this room. One lab is Clean and Resilient Energy System, which is more research-oriented lab, and we have research equipment over there. And another lab, we have electrical power lab, which is more towards teaching and these trainers and all those things which we use to train our students. So I will start with the Clean and Resilient Energy System, which short form is CARES lab. I will start with CARES lab equipment. And starting from here, we have DC power supply, which has function of simulation. So this DC power supply is a PV emulator. We can have different voltage rating for this with this power supply. We could have different. We can visualize different irradiation level and different environmental condition of solar. So this is one of the assets of this lab, DC power supply, which is programmable. We could change all those conditions for solar panel and see different effects. In addition to this one, another lab we have, which is AC power supply. This is also programmable, and this is 2 kVA lab, and the rating for this one is and we can also change frequency with this programmable AC power supply, which is 1 to 15 kilohertz frequency. Voltage is 0 to 300 volts. So this is another equipment which we have and we use for our research. We also have other Texas instruments. These are not part of this DC power supply. These are different boards which we use for our solar panel operation. And one of the board is actually working over here. One of the board we are using here, and this was today's experiment. And students are doing experiment. Do you want to say something about today's experiment? So in this experiment, we are actually doing MPPT operation, maximum power point tracking operation, where we are seeing that even if our load changes, our solar sends the maximum amount of power. So we can see over here, this is 32 watt maximum we are getting from input. This is input side, and on the output side, this is our load. Even if we change our load, our input power does not change. And this was the experiment our student did today. And this course is power electronics and integration of renewable energy system with our existing power system. So this is one of the experiments we did today. Joshua, do you want to talk about this experiment?
Yeah, sure. So just like Professor Khan said, we just finished working and understanding the concept of maximum power point tracking, which he just said is obtaining the maximum power from the solar panel at all times, even with a different load. And the way we achieve that is with this operation here, which is a flyback converter, which uses different duty cycles to change the load parameters with the given maximum power point or maximum power output of the solar panel, which we are using with a DC source today.
And additionally, we are also doing a real-time monitoring of the different parameters on the board, so that if we want to make any transitions, we can also do it from the software side in real time, and these changes would be reflected.
And before doing this experiment, we always give some explanation on the board and try to give all the fundamental concepts, how we are going to do and what we are going to do, all these basic concepts. So we spend around an hour on this board and explain all those concepts, and then move to our experiments. So this was some of our equipment which we use for our Clean and Resilient Energy System, which is more power electronics equipment and for renewable energy and for wind power plants. So we are also in process to get one microgrid, solar plus wind, both will be embedded in that microgrid, and we're going to have it over here. So in addition to all these, we have electrical power lab equipment, which is over here. So this is one of the workstation. Like this, we have 6 workstations in this lab, and each group we have 3 students in each group who does experiment on this workstation. So in these workstations, we can do different operations. So for example, in this operation we are trying to run our synchronous generator with a turbine. So these two are connected together, and a DC motor is behaving as mechanical power to turn this synchronous machine on. We have all these panels. We can use these panels for different operation, like for synchronous machine operation, for DC machine, for DC parallel shunt machine, for DC series machine, compound machine, and for induction machine. So we can all do on the same workstation. We could actually perform 20 plus experiment on this only workstation. So similarly, we have 5 other workstations for our students. This is motor control system, and if you see, we have electric motor over here, which is being controlled using this power supply, this is 3-phase power supply we give from our lab, and this is our 3-phase supply. If you see, we also make sure safety of our students. So we have lag out and lockout system installed. Students cannot turn on power supply without taking prerequisite safety measures. So after we're doing all those safety, we make these connections from operator station, from reversing contractor station, and from all these relays. We have different relays: overload relay station, indicator lamp station, to see if indicator lamps are used to see if anything is bad. So we connect through this motor connection station with our motor. If you see, we connect through this motor connection station with our motor, and so with this control system, we could do many operations. We could see inrush current of machine, starting of machine. We could install different kind of fault on different relays. We can install a fault over here in the transformer, in the reversing contactor station, in the overload relay. We can use different faults, and then we can ask our students to diagnose where the fault is, and if they diagnose correctly, we give them points for that. So this is one workstation which we use for our motor control, and motor could be different. For now, it's induction machine. We can use different DC, synchronous, all those machines. This is another workstation. So we have facility of motor control system in our lab. We have also 3-phase supply facilities which we can get from this lab, from this 3-phase supply. Further, we also have this hammer-down equipment. This is power electronics trainers. We use it to do some power electronics equipment experiments which we were doing over there. So this is another equipment we use. In addition to that, we have this process controller. This is a real process controller which our students see on our marine system. You see, we have all those water channels over here. We could use this to give a similar exposure which our students can have on a ship. And this is similar to this process control system. Other motor control systems are giving the same experience to our students as we get on a real ship. This is a storeroom for our lab, electrical power and clean and resilient energy system labs. So you can see we have some surplus motors to use. So if you see, this one is industrial motor. We have some new machine. We have some old machine. We use this machine not to operate, but what we do with these machines, we ask students to open these machines and see how the internal construction of machine is. Where is our armature, where is our rotor, how the winding has been done, and all those features, where is the capacitor, all those things. So these old stuff, we also use them for students to visualize inside the machine what's going on, how we wound these machines and all those things. So these are machines. We have a lot of equipment in our store. These are old machine, new machine, and this is hammer-down equipment where we can get 150 volt DC. This is a huge amount of DC voltage, 150 volt DC, variable DC supply, 0 to 150 volt DC. We can from the same supply we can have DC voltage, and now we can also have from 0 to 140 AC volts. So this is another equipment. We have these are hammer-on equipment, which is kind of traditional one, which we are replacing with a new equipment. These are loads. So if I could show you, these are different kind of load. This is capacitor load, 250 watt capacitor load, and the bottom one is maybe inductor load. So we have all kind of different loads, resistive load, inductive and capacitive loads. So all kind of these things. So yeah, and we have also some communication equipment which we do not use in this lab, but we have a lab, electronics lab, where we use this equipment. And sometimes we ask students to play with all these equipment which we are not currently using. We have transformers, we have all DC meters, some AC meters, so we have a lot of equipment which our students play. So yeah, that's it. I was talking about our lab's research, and if you could go and check our lab website, tamark.edu/cares, you will find more of our projects, more of our paper, our recent publications, our recent announcements. We are always looking for graduate students, undergraduate students who have potential and who want to actually contribute to the current issues, especially resiliency of power system. Recently, Texas got a severe power outage during storm. So we are working on resilient power system. This is another area we are working in. So we are always looking for motivated and excellent students who could contribute to the challenges we are facing, both in marine power system and also to the energy system, overall energy system of Texas and USA. So our collaborators are all over the United States, all over the world. We have collaborators in the United States, in Mexico. We have collaborators in China, India, Iran, Middle East, South Africa. So different countries, Denmark. We have so people are working with our lab. We have visiting scholars we have one visiting scholar from India, one from China. We have one visiting scholar from Pakistan. So we have a diverse set of people in our lab, and we are always looking for more individuals who actually they want to do something for the country and for the system, for the power system. So I was talking a little bit about our components. So this is the mechanical load. We call it Brownie brake. We use this load to put load on our machine. So if you see, we place our shaft over here and we tie this knob, and it put a lot of load. So from here the scale, we can see from the scale how much load we are putting. We place this Brownie brake, this is load over here and over here, and then our machine is here. So if you see, this is safety guard for our students, so that the shaft does not come out. So as I already talked about, the safety of our lab, our students, of the instructors, is our prime importance. So we take it very serious. These are the mechanical equipment which we use to combine motor with generators. We have different shaft keys, and we have different tools we use to work on our machines. So we also have different meters. Let me grab these meters. So we have different meters. If you could see, we have multimeters, digital multimeters, which we can use voltage, current, impedance, continuity. We have speed, RPM meter. We could use these meters. We have ammeters, clamp meters we use. So we have all kind of meters. We have different oscilloscopes. I just showed us one of the DSO over there. We have fluke meters there, DSO. We have old DSO. So we are blessed that we are at Texas A&M, which supports such kind of innovative research and always supports with funds. We get a lot of funds, and all these we recently purchased around $50,000 equipment, power electronics equipment. So we are blessed that we are at such our one research institute who supports such initiative and helps their faculty member to progress and do something new for the society and for the country. Thank you so much.
Hi everyone, I am Syed Rahman. I am a second year PhD student working under the supervision of Dr. Khan, and I am a member of the CARES lab. So in addition to the power electronic equipments that we have already seen, these are the other set of components that we have, sort of discrete components that we can use to realize the new circuits that we are trying to come up with. And they vary mostly from the advanced switches like wide band gap switches, and in addition to that we have powerful FPGA processors for executing the control algorithms. Whatever we have developed, they can operate at frequencies up to like 100 megahertz, like 10 nanoseconds step size. And in addition to, we are using these things and the other test boards that we have to develop innovative circuits and control algorithms to address problems in the areas of EV fast charging and renewable integration to the utility grid, along with the cold ironing concept of marine ships.
Yeah, I think we did not talk about our research interest where we are doing our research. So we are working, so most of our research is in power electronics and power system, but our applications are very specific. So one of the application is EV, electric vehicles, and in EV we are working on super fast EV charging schemes, and then its impact on the distribution system. So when we connect our EV with our local system, there's a lot of problems, harmonics, voltage dips. So there are several issues. So we are trying to analyze and see what are the challenges with this super fast EV charging. This is one area. Further, we are also working on shipboard power system. In the shipboard power system, what we want to design a cold ironing, a microgrid on the port for our electric ship. So when ships come to the port, its engine should be off because the demand is less, power demand is less. So we want to feed our feed our ship with our local microgrid, but with that microgrid we want to be renewable energy based, solar, wind, tidal energy based microgrid. This is another area. Other area we are working is in the aerospace. We are designing aircraft to power system architecture, which is more reliable and which is more efficient with lesser number of components, lighter F-35, F-22 power system architecture. That's what we're working in. So we are working on multiple areas, but focus is on power system and power electronics.